Hello everyone. Today we'll be solving problem 15.21, which deals with spur gears. We will focus on figuring out gear dimensions such as the diametral pitch, or uppercase P, which means teeth per inch, circular pitch, lowercase p, and base pitch of a gear, which is PB. We will also be looking into interference between gears and gear teeth, and how to determine if there will be interference between them. Lastly, we will focus on solving for contact ratio, which means the amount of gear teeth in contact with another gear's tooth at any given time. So the problem states, a pair of standard 20-degree spur gears with 10-inch center distance has a velocity ratio of 4.0. The pinion has 20 teeth. In part A, we'll be finding the diametral pitch, the circular pitch, and the base pitch. So we're given in the problem here the pressure angle is 20 degrees. We are given the center distance as 10 inches, the speed ratio of 4, and we're given the number of teeth on the pinion as 20. So how we solve this is first we use a couple relationships that we learned from class. So we have the average of the diameters of the gears should equal the center distance. And then using the speed ratio, we can retrieve the diameter of the gear in relationship to the diameter of the pinion. So it's really all plug and play here, and you get your few values for your diameters. And then once you have the diameters of the gears, you can use those to find the number of teeth on the gears, which should have the same ratio. In this case, it's 80 here. Then using some other formulas we use in class, we can determine the circular pitch and the diametral pitch. And here, we determine it to be 5 teeth per inch. Now, the diametral pitch will usually have an integer value. Base pitch is calculated using another relationship we used in class, but one small note to note here is that the circular pitch is equal to pi over the diametral pitch, and that's a relationship we're using here. Now in part B, this is not my drawing, but I thought it was the best explanation of parts you need to determine or draw. And in this drawing, we need to identify the addendum, which is the absolute top of the gears, so the teeth in here, and then the dedendum, which is the bottom of the gear's profile. Continuing part B, we also need to identify the pitch circle, which is the circle here, the pressure angle, which is the gear teeth profile, and the base circles, which are here. Next, in part C, we need to determine the maximum radius of the addendum, or the maximum acceptable radius of the addendum. So that will be from here all the way to the top of these profiles. So this is the gear and this is the pinion. And again, it's just formulas we learned in class, and it's just plug and play. Now the radius of the gear is half the diameter of the gear, 8 inches. Same thing for the pinion. And we use these values to plug and play, and we get our maximum allowable addendum radius for our pinion and for the gear up here. I'll leave a while to copy. Next, in order to determine if the gears will have interference, we need to calculate the addendum. not the addendum radius. This is just the addendum. And the addendum is, I believe, from here to here. Yep, from here to here. After calculating that, we need to calculate the addendum radius for the gear and pinion in our case. And if it's under the maximum allowable, there will be no interference. In this case, there's no interference between the gears. In the last part, we need to draw the contact ratio. So that will be this line here. Oh, and in part C, RA max is just the radius of the addendum. Now for the contact ratio, all we're doing is using this big formula. We have all the numbers from the previous questions, and we're just plugging in play. We get a contact ratio of 1.69. Now this is between 1 and 2, which is an acceptable value.